Greetings and welcome back to the module 3 of spectroscopy, namely distinction of NMR spectroscopy. The objective of the session is to understand the dissimilarity of NMR spectroscopy with other molecular spectroscopy. The outcome of the session, the learners will be able to distinguish the NMR spectroscopy with other molecular spectroscopy techniques. Before going to the topic, let us recap the module 1 and module 2. In module 1, we have seen the electromagnetic radiation and its type. We learnt spectroscopy is the study of interaction of electromagnetic radiation with matter. If the matter is atom, then it is called atomic spectroscopy. If the matter is molecule, then it is called molecular spectroscopy. If the spectrum which is measured is absorption spectrum, then it is called absorption spectroscopy, whereas the spectrum which was measured out of the emission of radiation by the matter, then it is called emission spectroscopy, which we have discussed in the module 2. NMR, nuclear magnetic resonance spectroscopy, is a molecular spectroscopy which comes under absorption spectroscopy. And now let us discuss the dissimilarity between the NMR spectroscopy with other molecular spectroscopic techniques. Generally, in the case of UV visible spectroscopy and IR spectroscopy, where the electromagnetic radiations interact with the molecules, thereby the molecules gets excited from the ground state to the excited state. Which is separated by the energy difference delta E. In the case of UV visible spectroscopy, if you irradiate ultraviolet radiation, then there will be an electronic transition between the energy levels. If we irradiate infrared radiation, then there will be a vibrational transition takes place between energy levels. In short, in these molecular spectroscopy technique, the interaction of electromagnetic radiation with the molecules or atoms takes place, whereas no magnetic fields are used to create energy states because already the energy levels are available in the molecules. Excitation used to take place between the energy levels upon interaction with electromagnetic radiation. Whereas in the case of nuclear magnetic resonance spectroscopy, the interaction of electromagnetic radiation with the nuclei happens, which is in contrast with other molecular spectroscopic techniques. Magnetic fields are used to create energy states which are again a distinct, which is completely different from other spectroscopic techniques. Flipping of protonic spins used to take place, whereas in the case of other molecular spectroscopy, excitation used to take place. And we will discuss in our next module what is meant by flipping, why magnetic fields are used, and the interaction of electromagnetic radiation with which type of nuclei used to take place, or the things will be discussed in our next module. In this module, the objective is to distinguish or find out the dissimilarity between the nuclear magnetic resonance spectroscopy with other spectroscopy. If you take the excitation mechanism of nuclear magnetic resonance, here the energy levels are degenerate. If we apply the magnetic field, the energy levels are creating. If you irradiate the electromagnetic radiation, excitation used to take place, that is flipping. So I repeat, the dissimilarity between the NMR and other spectroscopy. In NMR, the interaction of electromagnetic radiation with the nuclei takes place. In nucleus, we don't have energy levels, so magnetic fields are used to create energy levels. Between the energy levels, flipping of protonic spins used to take place. These 3 points are completely contrary to the other molecular spectroscopic techniques, which will be discussed in the unit 1, 2 and 3 of the spectroscopy in other modules. Thanks for your participation. Kindly clarify your doubts by attending an online session in a Google Meet platform. The link and the timetable will be shared through the WhatsApp group. Thanks for your active participation. Thank you one and all.